My name is Geon-Il from Seoul National University. Before I start my presentation, I want to thank to the organizer of this workshop. So today I'm going to talk about the ocean warming-induced El Niño changes. So earlier main speaker talked about hysteresis. As you know, hysteresis of many climate factors such as sea level, precipitation, AMA, and ITCC has been reported. Not only these climate factors, but also ENSO, which has large variability of the tropical Pacific, is also reported. When CO2 return to control level, Eastern Pacific SST variability still increase with extreme marine events. When it comes to question why the climate does not really recover, the ocean is important key. The ocean play a role as energy observer to global warming. However, when CO2 decrease and atmosphere cool down, the ocean can be his source for the surface climate system. The recently paper suggests that the ocean warming-induced irreversible climate change produces the specific spatial pattern, especially tropical region. Then, what about answer? In this study, we investigate how the ocean warming induced the change in ENSO characteristic. To investigate the answer for this question, we use two experiment sets. First is idealized CO2 ramp down experiment, which was conducted by Professor An's group. In this experiment, they simulate the climate recovery process, ramping up and down CO2, and then fix it. The other is initial warming experiment. This is same model, but this is fixed CO2 simulation. However, the ocean temperature anomaly is added to initial condition as a forcing, which was calculated when CO2 reached current level in ramp down experiment. We also adjust the depth at which forcing was added. All depths below 100 meters and 700 meters. Through the comparison and analysis of these two experiments, we can investigate the impact of the deep ocean on climate recovery. If the mechanism is the same in two experiments, we can conclude that deep ocean warming induced ENSO change during climate recovery. So first, we check the change of the tropical mean state. So top figure shows the SST difference between restoring and PD period. As you can see, there is a El Niño-like warming pattern with stronger warming in Eastern Pacific. The bottom figure shows the SS change in initial warming experiment. You can see this pattern is quite similar, with pattern correlation of 0.97. When heat released from deep ocean to surface, it is more efficiently transferred in strong overland region. So it is the reason why there is a linear-like warming pattern. We also check precipitation change. So as you can see, increased precipitation in equatorial region indicating southward shift of the ITCG. Northern hemisphere has smaller heat capacity, so it's cooled much faster. Therefore, ITCG move relatively warmer southward, southern hemisphere. So tropical wind state change such as like warming and southward shift ITCG can induce the change of ENSO characteristic. So we calculated the change of the standard deviation of Niño 3 depth. You can see the standard deviation increase in all experiment compared to present climate. So this suggests the diffusion warming enhance the SS variability over the Eastern Pacific. Also, we conduct an ENSO composite analysis. The top figure shows the spatial pattern of ENSO in present climate, and its change was shown in the bottom figure. So there is positive signal in Eastern Pacific, meaning that enhanced ENSO in Eastern Pacific. Also, this result is consistent with increase in Niño 3 standard deviation. So this change could come from enhanced ENSO amplitude or change ENSO diversity. So to explore this further, we track the ENSO center. This figure shows the occurrence of ENSO center. Higher value, the more ENSO occur with this latitude. So as you can see, the occurrence of El Niño shows bimodal pattern with distinction between CP type and EP type El Niño. The frequency of ENSO events significantly increased in Eastern Pacific, especially there is significant decrease in CP-EP ratio here in our experiment, indicating more EP El Niño events. As you know, EP El Niño is more stronger than CP El Niño and is related to extreme case. So we further check the change in extreme El Niño case. As you can see, there is a significant increase in our experiment. The occurrence of extreme events increased up to by 40 to 80% due to diffusion warming. So how does diffusion warming induce increase in Eastern Pacific El Niño? Right figure shows the change ocean temperature vertical profile due to diffusion warming. As I mentioned, the warming signal is spreading from deep ocean to surface, especially in Eastern Pacific where this vertical mission is strong. And then surface warming further enhanced by Bjerkreim's field. Therefore, the vertical gradient temperature is increasing upper layer, indicating the ocean become more stratified. This enhanced stratification makes the oceanic response increasing upper ocean layer. So this figure shows the current response to wind stress in present climate, and its change was shown in bottom figure. So positive value in here, indicating enhanced upper ocean response. But why has the ocean response not only intensified upper ocean layer, but also shift eastward? It is because of El Niño-like warming and southward shift of ITCG. So this El Niño-like warming and southward shift of ITCG enhance precipitation response to SST. So this figure shows the response of precipitation and wind response to ENSO, and its change was shown in bottom figure. So as you can see here, there is dipole pattern suggesting indicating the ENSO system moved eastward. In particular, the region of strong westerly region of strong current response. So this is by summary. Even if CO2 return to current level, so continuously heat release from the deep ocean could make tropical wind state change, such as El Niño warming and southward shift ITCG. This induced the easterly shift lensor system and enhanced operation response. Therefore, EP type and extreme El Niño increase. So this study was published a few weeks ago in Nature Communications. Thank you.